Let me get this thing fixed up here. Sorry guys, I'm trying to get this straightened out. Hopefully you guys can hear me now. Alright, hopefully you guys can hear that. Let me get rid of that. We're totally not ready for tonight. So I'm trying to get this all straightened out here as we fly. Just get the phone off so we don't have to hear anybody. Anyway, so we're running really late there. Just finished up a chassis job, got run over really late, and I've been out of town, and for the 4th of July weekend we were working on the NASCAR Cup car, so trying to get that thing ready. And hey Bill, thanks Bill, so you hear me? Good. I had swapped mics in the last seconds. And the thumbnail's got the wrong episode on it, but whatever, we'll fix that later. Yeah, so been working on the NASCAR Cup car. I got hood repaired, got some more cleaning, a lot of sanding, some painting, trying to find parts for JFZ antique calipers that have been out of business for years, but slowly making progress on that stuff. And was out of town yesterday working on Smurf up in Central Florida, so I was gone the entire day. I left the house at 6 and got home at 10:30 last night. So really put me behind the 8 ball here at the shop, trying to get all this stuff well, nothing's actually prepared, but trying to get prepared. But that's, it goes like that sometimes. I got some pictures, tried to get some more electronic stuff for you guys. I don't know I don't have anything organized, so it's going to be kind of a hit or miss deal here. Let me see here. Does that have everything on it? I think it does. So hopefully we won't have any issues with dropouts and everything like we did last week. I apologize. And unfortunately, I haven't had a chance to even check any of it to see what was going on with it. So hopefully we don't have that issue tonight. Rick's on. Hey, Rick. Thanks for helping me last week with the differential issues. Appreciate the input. Yeah, no problem. That's what I'm here for, man. I love helping out and trying to, steer people in what I think is correct direction. It may not be everybody's correct direction, but it is what I can do. Tell you what I know. That's all I can do. But yeah, Rick's project is gonna be really cool. Now that the kids are gone, and well, you got a grandbaby now, so right now it might be okay. But as soon as they start getting a little bigger, you're gonna be tied up with grandkids. So you got probably about a year and a half to get that 55 running. So I'm just teasing you. But it would be cool. Just get baby seat hooked up in the back seat and take your grandkid out for a Sunday cruise. How cool would that be? We'll have to see. I don't know if Chris made it on last week. I heard his car was at the dyno shop. Hopefully, that was a week ago or so. So hopefully he's got that thing moving in a forward progress. And of course, Bill and Dawn were at the track last weekend. I don't know if Dawn saw my email. I need you guys to send me a current file on the current global file so I can lay that over the data recorder to see what was going on. But I will, if you guys can send me that tonight, I'll look at that stuff tomorrow. Hey Ryan, glad to see you in tonight. If you came in late, it's great because this was a really bad start out. Okay, thanks Bill. Yeah, I got way behind the 8-ball, finished up a chassis setup and alignment, and that took us all afternoon, and next thing you know, I looked at the clock and it's 6:35 and I have nothing prepared for tonight. So I started scrambling, and I've got some stuff, so we'll have some stuff to talk about and stuff. Continuing on with our electrical stuff. So I know it's been a couple weeks since we've been down this road, but you know, we were talking about laying out your wiring schematic, your wiring plan. I'm always later behind. No problems, man. No problems. We all are. We all are. Ah, Chris, you're in. I was just talking about you. I don't know. Did you get? Was Justin able to get some of the tuning done on your car? I know he was working on it. While I was on vacation, I think I talked to him and he was working. I think he got the pump gas tune kind of sorted out, maybe. I haven't talked to him in a week or so, so I'm not caught up with what's going on. Yeah, so on the wiring stuff, you know, we originally started out with how to prepare by, you know, finding all your instructions and making a roadmap of some sort, whether you do it on a spreadsheet or just on paper and you handwrite it, but just so you kind of get an idea where all your components are going to live and what wires need to be hooked up, and then what wires get integrated into the main harness, so you can just kind of get it all laid out and everything. And then we did a show on the style, type of crimps and connectors and all that kind of stuff, and we did one on actually making proper crimps and what tools to use for that. So tonight I thought I would go into more of the components you need for switches and stuff like that. So I'll go to the screen now. I don't have this in order, so we're going to just kind of bounce around a little bit. Hope you don't mind. So this is your actually this is not the one I wanted. Sorry, we'll hold that one. This is the one I wanted. So alright, come on computer, keep up. Alright, so this is a standard, no, that's actually not the one. It's the one. Okay, so this is a standard 4-prong relay. And what relay is a high amperage switch. So to turn on a water pump, a fuel pump, a fan, anything that's going to draw over 10 amps, you should put a relay on, because the relay will take all the load, and your toggle switch or whatever you're using, your ECU or whatever you're using to activate that switch, won't have to carry the load. It only needs to carry the load to activate the relay. Now, on your standard wiring, and I may have said this wrong in the past, but I've done a little research and now I'm comfortable that I'm totally correct. 85 is usually the ground side of the coil. This emblem here is a coil that when it energizes, it moves this switch. So this is, the 85 is always your ground side, 86 is your power side. Now you can switch power or ground. It doesn't matter which one you're switching, you just have to switch one of them. So when this has got ground and this has got power, this electromagnetic coil will then flip the switch and connect it. So 30 is your battery load, or the voltage coming from whatever load capacity you have. Typically it's a battery, or it's power strip or something. And then 87 goes to your component. So once it turns on, it flips the switch. This completes the circuit, and now you've got a high amperage flow here, but not through your switch over here. Now, so here's a picture of a regular standard coil. Now, here's your 30, and it's gold. Typically, it's gold, but it will always be in a different shape. All your other spades will be going one direction. The 30 will be going in the opposite direction. And then there's your coil, which is your 85 and your 86. And then this wire here goes through the back, and that's your 87. So when the coil is activated, the points jump across. And actually, I am wrong. I am sorry here. So this is your 87, because I'm just looking at this coil. So here's where all your power is all the time, and the electromagnet sucks that down and draws it into here. So this is actually a 5-prong relay, where this one is always making contact, and then you put power to make it open, and you make this one close. So that may make it a little confusing for you, but a 4-prong relay is, when it's activated with power and ground, it sends the signal through it. A 5-pin with a normally closed control that goes to 87A, and that would be if you want to have something you wanted to open with power. We would use 87A on like a nitrous trans brake type situation, so that when the trans brake's on, the nitrous is off. That's not the picture I wanted, though. Sorry, like I said, I don't have these all. What is going on here? There, this is the one I wanted. So this one, here's a 87 of a 5-terminal. So you got 3. You got 85 your ground, 86 your power, 30 your power to your load. And then you got your 87, 87A, which are both load circuits. So this, on a 5 circuit, you can see that the points are always making contact to 87A. And your 87 standard is open. When this coil is activated, it draws this switch to 87. 87A becomes open, 87 becomes powered. So what you would use this for, a common use for, is on a drag race car. You've got your nitrous. You want your nitrous to activate as soon as your wide open throttle, but you don't want it to be on when you have the trans brake on, because your foot's to the floor, so that would activate the system, but you're not going anywhere, so you don't want that activated. So what you would do is 30 would be your battery power. 87A would be your nitrous solenoids, your power side of your solenoids. 85 would be your ground, and 86 would be your switch from your trans brake. So, or actually it could be 86 or 85, depending on if it's a power or ground switch. But let's just say your trans brake is a power switch. So you activate the trans brake, which is a separate circuit from this. So that when you activate the trans brake, it sends voltage to the 86, which then draws the switch to 87 that goes to nothing. So while the trans brake's on, the power going to the nitrous solenoid is disconnected. As soon as you release the trans brake and the voltage is released, 86 becomes open, and this switch pops back to 87A, and your nitrous turns on. So you're using a power source to disconnect something. So that's a way of, you would use a 5-terminal relay. Now you can use a 5-terminal relay and not use 87A, and it'll work like a standard relay. But if you have something that would be on continuous and you want to open it, that's how you would do it, using the fifth terminal. And a good thing about that it would be is you wouldn't want your relay on all the time, so that's, you know, you could do it use it for that type of situation. And we talked about this before. This relay has a diode in it, so it doesn't have a voltage flyback. And what that is, this is a coil. So when the power goes away or the ground goes away, this coil is still holding power, and it's going to feed backwards through your circuit. So if that goes backwards to an ECU, it can knock the circuit out, knock the driver and the computer out. So this diode kills that. It only lets the current go in one direction, but it won't let it go backwards. Chris, belt slipped on the dyno. He needs to diagnose the problem. Going to see if the balancer is not pinned, not pegged. Also looks like I might have to upgrade to an 8-rib system, which you would like to talk to you about. Sure, no problem. Yeah, first you definitely need to see if the keyway if the crank is pinned. Being a stock engine with a stock balancer, there is no keyway in an LS engine. Okay, you should hear from him tomorrow. Okay. Yeah, I think that's what he was telling me when I talked to him, that he was having belt issues. And I don't know if you were having these issues before. You might not have even known that it was doing this stuff. Because without it on a dyno, you wouldn't really see it while you're driving. So, yeah, give me a shout tomorrow when you hear from him, and we can go over that stuff. All right. So on these relays, I was kind of going over this diode, or some will have a resistor, but that stops flyback. So what Holly gives you, or not gives you, you have to purchase. But they have, why is this doing that? Okay. They make this little kit, and this is a flyback control for trans brake, but it just has a diode in there so that when you release your trans brake soldering, which again is electromagnet coil, you don't get a voltage spike going backwards into your ECU and burning it up. So that's same thing that they're doing there. Let me close these because I think that way it'll open properly. Where is my diode? All right, so here's what a diode does. A diode is a electronic one-way check valve. So they have these, you'll see these black coils with a silver band and wires coming, solid wire coming out either way. And you can get these in all kinds of different amperage outputs. And if you've ever installed a MSD 6A, 6AL, 6T box, or any of the other multiple spark boxes from MSD, a lot of times it would come with one of these in the kit. And the reason being is some of the older GM cars, the way the car was wired, once you put the MSD box in, the MSD box current would make the car not shut off, because the box is going to stay on, because anything in the car that's creating a flyback signal would energize keep the box energized, and the car wouldn't shut off, or may shut off after a couple, 30 seconds or a minute or so. So they would give you one of these diodes to put in line, and that would stop that from happening. So the way you can tell you have to wire a diode in is, you see there's a stripe, and there's your connections, and here's a electronic diagram of how you would see it on a schematic. And you always remember this. So the flow is going in the direction of the arrow. Okay? And the flow cannot, when it goes back the other way, it hits a brick wall. That's how I always remember it. The arrow can open, split the brick wall, but when the current goes the wrong way, it hits a brick wall and stops, and it doesn't allow it to go back any further. So that is what the use of a diode is. So anytime you want to circuit protect something, you may have seen before, you shut a car off and you'll hear some of the units in the car still staying on, and you watch your cooling fan. As the cooling fan slows down, everything starts dying in the car, because what's happening is the winding in the coolant fan is backfeeding the engine. So what happens is when you turn the key off, it becomes a generator, and it sends voltage in the opposite direction and keeps things powered up. So that's when you would put a diode in line so that that wouldn't happen. Same kind of thing, different subject, but when you put a 2-post battery switch, a 2-lug battery switch on a car, on your battery cable, say you put it, racing, you usually have to put a battery cutoff. So you have your battery power wire or ground coming from the battery to one post, and the other post goes to the front of the car, and it goes to your alternator and starter and all the other things that you're going to feed in the car. So when you turn that switch off, it kills the power to the car. Well, the problem with that is if the car is running, the alternator is putting out voltage. So when you shut the battery kill switch off, the car keeps running because the alternator is keeping the car energized. Back in the day, before we had electronic devices in the car, that was a mechanic's way of testing the generator or alternator, was to go up to the car, pull off the battery cable, and if it stayed running, the alternator was charging, at least enough to keep the car running. You don't want to do that today with new cars with electronic devices in them, because it will send voltage backwards and it'll burn up your radio, your amplifier, your ECU, your ECU control unit for your vintage air, any other modules that you have in the car. They can burn up from that backfeed. So what you have to do if you're trying to get a car with a battery switch to shut off, per like NHRA rules and stuff, you would use a 4-post battery switch, and the 2 smaller posts would run your alternator through that. So your alternator is going all the way back to the battery, and when you break the switch, it breaks all 4 posts, and now the alternator cannot backfeed the car and it shuts the car off. Or you can put a solenoid. So here, let me go to a solenoid now. So there's a solenoid. It looks like a starter solenoid, but this is actually a continuous duty solenoid. You could use one of these to make the car shut off by using this to kill the alternator. These are really good for something. If you have something in the car that's going to be over 100 amps of current draw, then you want to go to something like this. The case is ground. You got your battery voltage in one side, your load out the other side, and then your 12-volt switch that turns it on and off would go to that post there. So back in the day, I used to use these for cooling fans, and they would really run good because you'd have clean, 80, 90 amps of power going to your cooling fans. You'd be surprised how much better they sounded than having a 30 amp relay on them. This is another same thing, just in a different design. You got your 2 posts. Now this one, you have your ground and your power post separately, so you can switch either one. A lot of the newer design race cars, that the batteries are, they're using lithium-ion batteries, and they're actually putting them in the cockpit. They're using these because they're putting a kill switch in the back of the car, but it's just an on-off switch, and that goes back up next to the battery where this unit is, and it kills the power. Kills the power there. So there's multiple ways of doing that kind of thing. Here's some more pictures of more diodes, just different. These are all exploded view. These wires are like 16 gauge or 18 gauge, so they're really small wire, but just magnified picture of them. I do not have these in order, so I apologize. Here's another picture of the relay. I didn't want to go back and bounce around, but just another way of showing it. There's your coil and your switches. So you can look this stuff up on Google. That's where I get all this stuff from. So when we talk about relay, let's go back to relays for a minute, because the diodes, we kind of got off on a sidetrack there, because the relay has a diode in it. That's basically why I got that in that direction. So most relays are of the electromagnetic kind, like we're just talking about. So here's another picture of one, kind of a little bit more exploded view. So you've got your normally open contact, your normally closed contact, and this piece is coming in from your high voltage, your input. They got a spring to make it bounce back and forth, and there's a strap that just sends the power up here to the contactor. So obviously you can see there's points. You know, when points pop, they usually throw a spark. So that's where the flyback comes from. But you can see it's completely mechanical. You have this electromagnetic winding that draws a piston in, because it becomes a magnetic field, and that's what trips this connection here. Now, well, let me show you this. Here's a picture of a whole bunch of different style relays that we have in cars nowadays. There's all different shapes and types. 4-prong, square little ones, like in the later model GM. You got these miniature guys here with the wide spades. They're more like in Fords. They do make aftermarket mounts, so you can mount them. I use them a lot of times for fuel pumps and stuff, for low amperage stuff. These are good for usually 30 surge, 20 continuous. So they work good for fuel pumps and water pumps and stuff like that. I wouldn't use them on a fan or anything like that. And of course you got your sealed ones here that are completely sealed. So it's just a plethora of different designs and shapes, but they all do this basic same thing. And you either have a 5-prong, as these are, or a 4-prong. And you know now if it's got a 5-prong that it's got a normally closed circuit, and obviously the switch normally open circuit. So quick, easy way of seeing it. Look at a relay. If you see 4 prongs, it only works when it's energized. If it's a 5-prong, there is a normally closed circuit built in. It works when the relay is sitting dead. So all that stuff, all those type of relays, if you're going to use them on something electronic, they should either have a diode or resistor built in, or you need to put a diode in line to protect your devices. Now, they do have solid state. I don't know if this was a drawing. No, this is a regular coil. Yeah, it's another normal one. So I didn't get a picture of a solid state schematic. So a solid state, they call it SSR. This is an older designed one. And they actually have this one, you can see, is actually protected in both directions for your 2 legs. And you got your load side here. They have changed over time, and now we have Hella makes this one. It looks just like a regular Bosch or Hella regular relay, but this one is solid state. You can see it's got the fins on the top that dissipate the heat. And the nice thing about a solid state relay is there's no moving parts inside of it. So there's no flyback, and you can pulse these. So on a normal relay, being it's got an electromagnetic coil, So it energizes and then sucks the piston in, and that's what activates the relay. Well, all that takes time to happen. So if you're trying to pulse width modulate a control unit, you want to pulse your nitrous solenoids. You want to pulse your trans brake to make a bump in, so it rolls into the staging beams. Anything that you want to turn on and off quickly, a standard electromagnetic relay is not your friend, because it takes a certain amount of time for that coil to activate and deactivate. So it could take 2 or 3 milliseconds for it to activate and another 2 or 3 milliseconds to deactivate. So if you're trying to make something switch at 2 milliseconds, it's never going to work, because your timer is moving faster than the relay can move. Now on a solid state, because this has got, I don't know the actual terminology, but it's basically like a silicon pot, just like a chip or anything like that. There's no moving parts. When it senses load, it connects the signal to the output, and it's done. So these can work really fast, I think in like maybe 0.5 millisecond, so very fast. And that's why they have the heat sink, because it creates a lot of heat, because there's no moving part. It's going through the silica type composite that it's made out of. Don't quote me on the silicon, but it's something like that. So that's one style. Holley makes one that they use for their systems. Now you see on theirs it's only 3 connect. Let me superimpose that. On there's only 3, because they have an orange that's power in, blue that is power out, and black is ground. They're getting their power side of the sensing for the material to activate off the power side, so it only needs 1 power signal. So this is used for control by computer. The ECU always likes to prefers to pulse a relay on the negative side. So that's how they've got this one wired up. Your black with the yellow tracer goes to your ECU for your output, and then this controls whatever you want to control. Again, cooling fans, nitrous, trans brake, anything you could think of it you want to put a high amperage control unit to. Now they also, funny how Holley works, the Holley solenoid is $10 more than the NOS one, but guess what, they're exactly the same units. So if you need to get one, buy the NOS one, 15620 NOS. The 554112 Holley part number costs you about $15 more. Now the nice thing about solid state is we can do multiple things. This is the new MSD unit. So this one brings your power in here, power or ground, whichever way you want to pulse. And then you've got, these are your inputs, and these are your outputs. So this relay will do 4 different control units. So it's a pretty handy little deal. You can wire it in your car, and you can use this for 4 different things. You can do water pump, fuel pump, and 2 cooling fans. Door locks. You could do power windows. You can do anything you need to control with a relay. You can do it with this, and this is a solid state unit, so it operates super fast. And you just bring your signal wires in over here, and you can make them energize at will. Pretty neat little piece. It comes with some mounting brackets, and so you can stack these however you want to do. But it's nice, clean, and gives 4 relays in one little spot. Just cleans up your packaging a lot more. So that's basically your relays. Now, earlier I was showing you this duty cycle, this continuous duty relay for high amperage. Is a pretty big, bulky box. We used to trigger nitrous with these because there wasn't many options for high amperage load. But now with race cars with these big coil systems in them, smart coils, you got the 600 series MSD control. You got cars with multiple injectors per cylinder. I use these either from TE or from I just lost the other guy. But this is a 75 amp relay. So it's got a plug in under here you can't see, which is your 85 and 86, and you got your 30 and your 87, just like a normal relay, but this one can do 75 amp continuous. So I wire these in on my Dominator systems. Yeah, Chris, it's raining. You can hear it. I use these to power up the injectors and the coils on race cars that we're using the hotter coils in, and we need more amperage, or bigger injectors. You start running into the 300 up to 1,000 pound per hour racing injectors. They require a lot more amperage to operate. So instead of running a 30 amp relay, we'll run one of these 75 amp guys, and they'll do the job. Now again, this is a standard electromagnetic relay, not a solid state. They do have some solid states that are up in that high amperage area though. So the only other electronic piece that you would probably use in a vehicle for your main wiring type setup would be a resistor. Now, resistors are just what they say. They make resistance in a wire. So if you're running a late model GM alternator, or any alternator for that matter that is not a one wire, and it needs to sense, the voltage regulator needs to sense a charging bulb, you can use a resistor, and it will, you can find the resistance of a bulb. Usually it's about 100 ohms. So you can put power to, let me open this up so you can see these. Go on. Sorry I didn't have this stuff already pre-organized. I should have. So these are resistors, kind of same size and looks of a diode, but you'll notice these have a bunch of stripes, and those stripes denote how many ohms of resistance this unit has. So you can take a digital volt ohm meter and connect your red and black to each side, and it'll tell you how much resistance is in there. So the first time I really started messing with resistors is in the 80s GM cars, where we had the anti-theft chip built into the key. Well, they were not very good. As the car got aged, the ignition switch got worn. People got 20, 30 keys on their keychain, so it's the keys moving up and down in the ignition cylinder. Well, on those keys, on the ignition switch, they actually had two contacts that grabbed each side of that resistor, and the ECU was trained to look for a certain amount of resistance, and that once it saw that, it said, okay, this is the proper key, and we'll go ahead and start this vehicle. So when they would start wearing out, what I would do is I'd read the resistance of the ignition switch and cut the wires out away from the ignition switch and put a resistor with the same resistance in there, and now the car starts every time. However, you've lost the anti-theft portion of it, but at least, you know, on an old car that's not worth a lot of money, you're not buying an expensive ignition switch and having to worry about retraining the ECU and all that kind of stuff. So that was the first time I started messing with resistors. Now, the other thing, us old guys that worked on points cars, ballast resistor. Well, this is the same thing. This is a big resistor. It is in this porcelain container so that it has something to put off the heat that's coming out of the resistor. The resistor is going to make heat as it's resisting the voltage. And what these did was 12 volts would come from your key switch, and then this side of the resistor would go to your coil, so that your ignition coil only saw about 8 volts. If you had a non-resisted coil and hooked it up direct, it would burn up in about an hour, because there was too much voltage going, and it's superheating the coil windings, and then the top of the old cylindrical, boy, I'm murdering the English language tonight, coil were oil filled, so that plastic top would crack and the oil would start boiling out of it, and then the coil would short, and then the car shuts off and the coil's no good. So that was what the ballast resistor was for. Now some coils have an internal resistor to do the same thing, but like most of your Chrysler products and some Fords and some GMs would have a ballast resistor out there. But this is, again, just a resistor. And I like taking these off and changing the ignition out to a system that didn't use this. And don't ever touch these after the car's been running for a while, because it is hot. The new place that we're using resistors now is on these units. So if you've ever put LED lights in your car and you turn your turn signals on, all of a sudden the turn signals aren't working, because the turn signal works from heat, from resistance from the taillight bulb. It actually makes the thermal contact in the flasher heat up, and it retracts, and then once it cools, it comes back down and makes contact. That's what you hear the clicking, is that piece in the flasher heating up, going back on and off, on and off, on and off. So when you go to an LED light will light up with very minimal voltage. I mean, in the 0 point area. So a lot of times you get backfeed through your light switch or your brake switch. So you look at the car sitting in the garage and you see the lights dimly lit still, and you're like, the car is off, what's going on? Well, the thing is that there's something, it's getting a little backfeed. It would never hurt anything, because once it has a load on it, the resistance would go away. But with the LED, resistance there's no resistance in the bulb itself, so it connects the circuit, and that's why the lights are glowing. So you put these resistors, and again, they got heat sinks in them because they will get hot, but you put these in between your taillight wiring and your taillights, and that now it's gone. The resistor makes enough resistance to open the circuit. And I don't mean to keep bouncing around, but here's a good point. On a solid state relay, because there's no mechanical contact point, it's done through the potting of the material that pots the relay. If you have a relay that's not loaded to anything, it will show that it's on. So say like I ran into this on a trans brake. The orange wire on that Holley or NOS solid state relay, the orange is power, so that's going to your battery, and the blue would be going to the trans brake, and then the black yellow tracer goes to your computer, and that's what activates your trans brake. Well, my buddy Leo, his trans brake solenoid is inside the transmission, so you really can't hear it. So he was messing around with his car in the garage, and he couldn't hear the relay opening and closing, so he pulled the blue wire off the contact to the solenoid and put a test light in it. And he calls me in a panic, hey, the trans brake is on all the time. Whenever I check the voltage on the blue wire, it's got power. And it really, even though it shows power, there's no amperage. If you touch it to to ground, there'd be no arc. It's just because of this, the way that the unit is made, there's no mechanical components inside the solid state relay. It will pass a power voltage if there is no load on the wire. So anytime you're working on a solid state relay and you want to see if there's current going through the relay, you have to make sure that both ends are actually connected to the control units and check it that way. Check it at the connection with a backfeed pin or something like that. But if you pull it out and make the wire open, it will show that voltage is going through it, even though it's really not. It's just a leak of feedback that you're getting. So hopefully I didn't get this too screwed up and you guys might have picked up something on this. If you have any questions on this stuff, since we did bounce around, I didn't have this in an orderly fashion, please leave in the comments or on the chat now, so that we can, I can help you out on that. But relays and solenoids are really important, because even like if you buy a cheap fog light kit or something, the switch that runs that stuff will not take any amperage more than about 2 or 3 amps. So if you're trying to send the power through your switch and to the load, which would be driving lights or something like that, or whatever you're trying to, even your cooling fan, that switch usually cannot take the load. So you have to put a relay in line to be the handler of the load. That's going to do all the heavy work, all the heavy lifting, and the toggle switch is just going to do the work to tell the relay to do the work. Typically, whether it's electromagnetic coils, typically you will use 2 amps or less, depending on the size of the coil windings. Solid state take nearly anything, a milliamp, because there's no mechanical moving parts in it. It's just you're just completing a circuit, and then the material that it's made out of then completes the circuit, which can kind of be mind-boggling that there's a product in there that can move like current through itself with nothing moving. That's why I'm not an engineer. I know how to use the product. I just don't know how. I sometimes don't know the entire way it's made, but that's what they do. So when you're laying out your electrical work, and what the whole reason I was trying to show this stuff, when you're laying out your components that you're going to put in your wiring schematic, keep an eye out for how much load a certain unit is going to take, like your cooling fans or water pump or anything that's going to take load. The other good point is you want to add up all those components. Usually the manufacturers will give you a load factor. Say a cooling fan may say it takes 35 amps at startup, and then it'll go 25 continuous. Well, you want to take that 25, and you want to take what your fuel pump's going to do, and your radio and your amplifier and all the electronic devices in your car, all your lighting and all that stuff, and make sure that your alternator is putting out more amperage than all those components are using. I have a prime example on Mike's Trans Am that I'm currently working on. One of the complaints is it doesn't charge at idle, and it has an 80 amp alternator on it that came with a accessory drive kit, but electric fan, fuel pump, sniper system, old school factory air conditioner with a blower motor. It's got a lot of resistance in it. Then you got regular light bulbs, no LEDs, so they all take a lot of amperage. And sure enough, the problem is there's not enough amperage at low engine speeds to keep up with the demand that the car is putting on it. Rev it up to 2,000, 2,500, that gives the alternator enough RPM that it can go full load. and then it starts charging and everybody's happy. But when it's idling, it's probably only putting out, on this particular alternator, it's probably only putting out about 35 amps. And you can hear the cooling fan slow way down. And you rev it up and hold it at a high RPM, all of a sudden you can hear the roar of the cooling fan, because now it's got the proper amount of amperage to run at full speed. So, you want to, when you're at the drawing board stage of the build of your wiring schematic, you want to check all these things off, so that when you're done, it's going to work good. You wouldn't want to, if you, like with this Firebird with the alternator, you could have rewired the car and go, oh my God, what did I do wrong? It's not charging, and it's not, the fans, it's overheating at idle and stuff because the fans aren't running good, and it's all because the alternator isn't putting on enough amperage. And this car was not rewired, so we never went down that list. But when I saw the problem, that's the first thing I did. Okay, how much amperage do we need to support this car? And this car needs almost 80 amps at idle to keep everything running properly. So we've got a new Power Master alternator for it. It puts out at 80 at idle and puts out 135 at like 2500 and above. So that should fix his car, and won't have any more idle overheating. So that'll be tomorrow's job. But just trying to get everything, to show everything, to kind of enlighten, if you're going to do a wiring job, what parts you need and how you want to do it, so that when you're done, it works out perfect. Unfortunately, when we're building our hot rods, we're building one car at a time, and we're designing it one car at a time. And manufacturers, they'll have engineers build they do all the same stuff, but they're doing it that they're going to put into 100,000 cars. So they're at a different level than us. That's why a lot of times their stuff works a little better than some of ours, but that's the thing. Chris says should go with the 220 with the new pulleys. Well, I mean, again, you should see what amperage load you're going to have in the car. Kind of go through your components and figure out how many amps of voltage you need to control everything. Obviously, the more pumps and the more fans and stuff you put on there, the load becomes higher. So it's a very good possibility you may have to go 150 or 200 amp alternator. You do want to make sure when you're speccing an alternator that if the better companies will give you an idling amperage output and a higher RPM output. And you want to know that, because again, if the alternator is 220 amp at full speed, but it's only putting out 60 or 70 at idle, it still may not be doing the job that you need when the car is idling. So you just have to do your due diligence, figure out how many amps you need to keep the car running. So obviously your ignition's going to be a couple amps, but your fuel pump's going to be Chris, you got 2 fuel pumps in there, so you're probably in about 25 to 30 amps draw continuous. You got your cooling fan or fans, and they can be anywhere from 25 to 45 amp draw per fan. And then your intercooler pump, trying to think what other electronic parts you may have, electric motors you might have on there. Obviously your air conditioning, stuff like that. So you kind of want to figure out how many amps you're going to need, and then be able to set that all up. So the other thing is, when you underdrive or overdrive pulleys, that becomes another problem. Let me just send this sorry about that. Sorry about that. Somebody has asked me a question that I need to answer. Yeah, so the other thing is pulley sizes. You got to watch your pulley sizes. Um, on a supercharger, typically you put an oversized pulley on the crankshaft to turn the blower faster. But you got to watch when you get pulley kits and they have underdrive crank pulleys and stuff like that. That can create havoc with your charging system. If you're turning the motor, all the accessories 15 to 20% slower, it's great for getting rid of parasitic drag from all your components turning, but it also eliminates voltage and amperage at idle, and then you have other issues. So not always the best thing. You know, I know back in the heyday of the 5.0s, that was a big deal. Underdrive pulleys, pick up a couple of horsepower, but it doesn't always work so good. So yeah, look at your. If you go to any of your better accessory websites, PowerMaster is a good one. They have a whole tech page on pulley sizes and how to figure out your ratios. Because you don't, one of the things you don't want to over rev your alternator or any other component. Almost all components, power steering pumps, all those things have a max RPM they want to see. So, you know, you have to kind of figure out your pulley sizes and figure out what, you know, how high the engine's going to rev on a standard engine. It's not that big of a deal for the over rev portion, but on a high RPM engine, it does become an issue. So you have to watch all that stuff. You know, typically you'll see on a motor that's a high RPM engine that the alternator pulley is a much larger pulley than it would be on a street car, and that's because they know the motor is going to rev to 7,500, 8,000 RPM, and so they got to put a larger pulley on the alternator, slow it down so it doesn't over speed and the brushes explode or whatever, you know, whatever damage, overspeed the bearings and the bearings burn up. So, you know, things you have to kind of check. Unfortunately, when you're putting stuff together for your car, you kind of got to put an engineering hat on for a minute and make sure that all the components are going to work well together. So if you're not sure, definitely ask somebody. You know, we can go over that stuff. You know, you can text or email or send messages to myself or anybody in your area that you work with that is familiar with all this stuff. And just kind of go over everything before you start purchasing parts, and that way you kind of, when you get everything done, it's a match setup, because that's the cool thing and the hard thing with building hot rods is that we're buying components from all these different manufacturers and we expect them all to go together, and sometimes they don't always work that way. So you have to kind of do a little bit of engineering or at least fact finding, so that you can tell, are these components going to be compatible together, and you know, what do we need to do to make them compatible. So hopefully that makes sense. Hopefully you know, you guys got a good understanding of relays and you know, flyback voltage is really important, because almost everything we have, even in the aftermarket, almost all of our components nowadays have some type of ECU. You know, before, ECU used to mean engine control unit. It doesn't now. ECU is electronic control unit, because you can have any of your aftermarket AC systems, almost every one of them uses an ECU to control the servo motors for the heater control valve and for the defrost and heater vents that are in the case. You know, if you're putting electric power steering on, it's got an ECU in it. Obviously, if you have engine management, then obviously there's an ECU there. If you have a pulse width driven cooling fan, pulse width driven fuel pump, those all are run by an ECU. So you have to make sure that all those components are protected, because they are expensive, and you start getting weird electrical flybacks and stuff on those components, you can start knocking stuff out, and it'll get real expensive real quick. And it could even be to the point that you look at the manufacturer going, hey, you know, the part I bought from you doesn't work anymore, and it's really not their fault. It's a installation fault of what components you have in the vehicle. It may have been installed correctly for that particular control unit, but they don't know all the other units you have in your car, in your configuration. So that's why you got to kind of look at everything. Like I said, I like to get it on paper first and start writing your notes and try to find all these issues before you start either buying parts or at least start installing parts. And if you have questions about that kind of stuff, you can call the tech department of these companies and say, hey, am I going to have a problem with a flyback coming up, you know, into this control unit? And then, you know, you could put a diode or something in it to help alleviate that issue. So that's I guess the long and, well, the very short of relays. I'm sorry I didn't have more detailed information, and I definitely did not have it organized. But like I said, I was running really short on time and got really behind. So I think that's going to do it. If there's any other issues with electronics that you guys can think of, you want to put it in the comments after the show, and I'll try to go with it. Otherwise, I think next week I'll try to come up with something new that we can talk about. We've kind of been on this electrical part for quite a while with holidays and everything involved and vacations and stuff. It kind of got spread out, so I apologize about that. But I think we covered it pretty well, so should do good. Bill, how much sleep have you had in the last few days? Not much. It's the last couple of weeks have been crazy, but yeah, I got yesterday working up in Lakeland in Haines City. I was going from, I got up at 5, was on the road at 6, and got home at 10:30 last night. So, and you know, went to bed at 11 and got right back up at 5 this morning. So sleep has not been my strong suit lately. Appreciate that, Chris. I try to give you guys good information to forward everybody's experiences. And you know what, I did one other thing. Let me see if I can. I was working on the NASCAR during our 4th of July holiday. See if I can. I think I got some pictures in here that I can share before we leave. Well, these aren't in order, but I'll go ahead and show you some anyway. So here's some of the suspension components in the car. Is a front spindle, big 5/8 studs, and they got the spring perch so you can adjust the springs and stuff. There's the master cylinder. So on these cars, they're single reservoir master cylinders. You have, this one is the front, that one's a rear, and then there's a balance bar in the pedal assembly, so you can control which one gets the load, and of course that's the clutch over there. And you can see the car's been sitting for a long time, and all the brake lines have to be replaced. That's what I'm getting ready to do now. These are some old Lockheed master cylinders. I haven't found any rebuild kits for these yet, so I'm not sure exactly what I'm going to be doing with them. There's a rear brake assembly, and these cars have a floater rear end, so there's actually a hub, which I don't think I got a picture of. It's got the bearings like a dually truck would have, and then this is the drive flange that has the splines that go here, and these splines go into the differential, and there's the big caliper and brake pads and 12-inch rotor for the rear. It's an 1 3/8 wide, so it's a big, huge rotor. There I'm just measuring the piston diameter. I had 1 3/8 pistons, 4 of them in each caliper. Some mounting ears. There's the hub. I got to find this seal because the hubs are leaking grease and oil out of the differential. There you can kind of see there's the studs. It's face down, so not really good pictures here. Rear rotor. Oh, this is the front brake setup, and this has the larger JFZ brake caliper on it, which unfortunately JFZ has been out of business about 15-18 years. So we're trying to find. That's why I'm measuring the mounting ears to see if, in case I have to go to a different system. And you can see on the stock cars, they make a screw-on aluminum cap, and they have a radius on, so when they're changing wheels, it makes the wheels easier to go on and off. I guess I didn't put any pictures of the stuff I was rebuilding. That's that picture. Let me see what else I got in here. So I had to repair the hood on the car. No, I didn't get any of those pictures on here. Let's see. I think this is just new parts that I purchased. Yeah, we showed those a while back. Well, I'll get a better pictures and stuff for next week. In the middle of cutting the Lexan, I had to sand the dash and the rear package tray area because it was all rusty because it was just a flat black paint. Want to repaint all that stuff, get rid of the rust. I've been cleaning up the inside, getting more and more of the goo and ook and crap from all the stuff on there, and just trying to get it cleaned up so we can start putting it back together. So the rain's starting to pick up again. It's after 8 o'clock, so I guess I'm going to go ahead and let you guys go tonight. Thanks for tuning in. Again, I apologize that I wasn't very prepared, but we'll do better for next week. So I hope everybody enjoys their week, and I'll see everybody next Tuesday. See ya.